Good morning, all of you. This is Venkatesh. Today we are going to discuss about parallel resonance from the resonance unit. So here, resonance means the quality in a sound is being deep, full, and reverberating. That is, a sound by reflection from a surface or object. So, like in our word Telugu, so resonance is nothing but pratidhwani. So here we are discussing about the parallel resonance. So before we are going to discuss about the resonance, so we should know about the impedance, admittance. So here impedance is nothing but R plus Jx. So there R is nothing but reactance and R is nothing but resistance and X is nothing but reactance. So we know that the reciprocal of resistance is nothing but conductance and reciprocal of reactance is nothing but susceptance, and also the reciprocal of impedance is taken as admittance. Okay, so admittance y equals to 1 by z. So here when we are getting the resonance condition, so that means, so here, so the resonance condition can presence in any type of circuits. So the reactances, the capacitive reactance is equal to the inductive reactance. So here we are discussing about the parallel resonance. So this parallel resonance is nothing but anti-resonance. So it is occurred when the capacitive reactance Xc is equals to XL. So the frequency at which resonance occurs is called the resonance frequency. So when the XL equals to Xc, so when the frequency can presence, so the Xc equals to XL, that frequency is called resonance frequency of any type of circuits. So here we are taking the parallel resonance means, so simply you can take the parallel circuit. So here I am taking the parallel circuit. So any simple circuit, it is a parallel resonance circuit. They consisting of resistor with energy storage elements, and this one capacitive storage element and another one is inductive storage elements. So that's why the impedance of this inductor, that is RL plus JXL. So RL plus JXL, and it is minus capacitive impedance, that is a minus JXC. So we know that inductor, that is a reactances of capacitor and inductor. So that reactance is Xc and XL. So that is simply the impedance Z1 equals to RC and XC, or both are series. That's why RC plus XC and RL plus JXL. So that is, so here I am calculate the total impedance. So these two in this circuit, that's two lines are parallel. That's why 1 by R equals to 1 by R1 plus 1 by R2. Similarly, it is a AC circuit. 1 by Z equals to 1 by Z1 plus 1 by Z2. That is the total impedance. So here Z1 is nothing but I am writing R minus JXC and Z2 equals to RL plus JXL. So from this, so 1 by R minus JXC plus 1 by RL plus JXC XL. So 1 by Z is taken as Y, that is a admittance. What is that? Admittance. So that is a admittance. So Y equals to 1 by RC plus J 1 by XC. So here XC is nothing but, so 1 by 2 pi FC. So 1 by 2 pi FC. XL is nothing but 2 pi FL. So here omega is nothing but 2 pi F. So this is, so and also J factor. So J factor is imaginary term. It can, J is represents imaginary term, that is nothing but 1 at an angle of 90 degrees. So that's why it can shift phase angle. So if 1 by J is rewrite as minus J, we can write as minus J. It is an imaginary term. So that is Y is calculated. So for the simplification of imaginary terms, so if we can multiply and divide with the opposite term, that is a conjugate of this term, that is RC minus J by omega C is multiple with, so R plus J into 1 by omega C by RC. That means, so there we can get, so multiple and divide with the term of R plus J into 1 by omega C on numerator and denominator of these. So then we are getting a minus b into a plus b. So then we get a square minus b square. We can get a plus b into a minus b formula. It gives a square minus b square. So that is, so from this I am simplifying the equation, and there I am dividing the terms, that is a real part and imaginary part. So finally I am getting the y. So this is equal to g plus jb. So g plus jb. So here g is nothing but conductance and b is nothing but susceptance. So for resonance condition, the imaginary term is equal to 0, that is nothing but the susceptance is equal to 0. So from the above admittance, so there I am equating the b equals to 0, b equals to 0. So this is I am getting. So from this I am simplifying that circuit. I am simplifying the circuit and calculate the equation. So 1 by omega c r l square plus omega square l square. So here the omega is nothing but angular frequency, so that is a resonant frequency. That's why I'm writing omega r in the lastly at the last end. So by analyzing that these equations and simplifying the terms and bring the omega terms at one side and remaining terms at another side, and take the common of omega and then send it to LHS side of the remaining constant. So finally we get omega r equals to 1 by LC square root of 1 by LC into square root of RL square minus L by C by RC square minus L by C. So here RL is nothing but resistance nearer to the inductor and RC is nothing but resistance nearer to the conductance. So for ideal circuit, the RC equals to RL. So the both impedance resistance is equal. So at that time, what is the resonance condition? Resonant frequency omega r equals to 1 by root LC. So from the above condition, that is the FR equals to 1 by 2 pi root LC. That means what? So omega equals to 2 pi f. So that means, so that is equals to what? 1 by root LC. So f equals to 1 by 2 pi root LC. This is the parallel resonance of the circuit. Similarly, you can simply take any type of parallel resonance circuit. So that is simply a tank circuit. Simply you can take a tank circuit. So in the tank circuit, the capacitor in parallel to the resistor and inductor, that is RLC parameters. So here also you can calculate the parallel resonant frequency for this tank circuit. You can simply equate the susceptance is equal to 0. So that's why, so how to calculate the susceptance? That means we can simply calculate the total impedance of this circuit. So the total impedance means, so this and this, the two lines are in parallel. So that is what is the impedance of this? RL plus JXL. And what is the impedance of this? So this is Z2, that is minus JXC, that is a Z1 Z2 equals to that. So therefore 1 by Z equals to 1 by Z1 plus 1 by Z2. This is the parallel resistance condition or parallel impedance condition. So similarly I am taking this formula, and 1 by Z equals to 1 by RL plus JXL plus 1 by minus JXC. So here 1 by Z is nothing but admittance and RL minus JXL. So that means the conjugate of this. So conjugate of this. So RL plus JXL, the conjugate is RL plus RL minus JXL, that is the conjugate. So then the multiple of these two, you can get A plus B into A minus B. So then A square minus JX XL square. So here J square equals to minus 1. So that's why you can get J square equals to minus 1. That's why here I am getting that R square minus JXL square means J square equals to minus 1, that is equals to plus. So RL minus JXC, and here the denominator consisting of minus J. So this minus J send it to numerator, that is going to plus J by XC. So therefore I am equating the terms. So the real parts and imaginary part. So this real and imaginary part I am separating the term, that is G plus JB. So here G equals to conductance, that is a 1 by R, and B equals to susceptance, that is 1 by X. So R is nothing but resistance, X is nothing but reactances respective inductor or capacitor. So for satisfying the condition for resonance, the imaginary part is equal to 0, that is nothing but susceptance B is equal to 0, that is B equals to 0. So then from the above equation 1, I am equating the susceptance equal to 0. Then I am getting that simply, so X equals to 1 by 2 pi Fc, so equals to 1 by omega c, and then XL equals to 2 pi FL, that is omega L. These terms are, we know that. So therefore, so from the above solution we are getting this omega c equals to omega L by RL plus omega square L square. So similarly you can take the omega terms at one side and remaining terms at the other side. So therefore omega equals to this equation, that is a resonance frequency for the tank circuit, that is omega equals to 2 pi f, that equals to square root of 1 by LC minus over L by L whole square. So this is the resonance frequency of the any type of tank circuit. So here I am writing a one problem, so that is for the tank circuit